We are going to solve an example of hypothesis test with p-value approach. 1 liter milk cartons should have mean content of 1000 milliliters. To check whether the mean has changed or not, we select 50 cartons randomly and calculate the mean. The calculated mean for the sample is 995 milliliters. Because it is the mean of the sample, we denote it by x bar, and this 50 is our sample size here. Assume that the standard deviation of all cartons content is 25 milliliters. Since it is the standard deviation of all cartons, so it is the standard deviation of the population, and we denote it by sigma. Now we are going to see whether the sample provides evidence at 5% level of significance that the population mean has changed or not. So here actually we wish to provide evidence from sample that mean value of the population is not equal to 1000 milliliters. So the thing that we would like to prove is this. So it is our alternative hypothesis. So we can define the null and alternative hypothesis here. Alternative one is mu is not equal to 1000, and the null hypothesis is mu equal to 1000. So here actually we want to reject H0 if x bar, the mean of the sample, is sufficiently different from 1000. Okay, so it means that we reject H0 if the mean is sufficiently smaller than 1000 or sufficiently larger than 1000. Here in this example, since the sample size is 50 and it is large enough, we can say that actually x bar is normally distributed by mu and sigma square over n by central limit theorem. Okay, so when we want to find the test statistic, when we want to find it, we see here that sigma is known and it tells us that we use the z values to find the test statistic in this example. So the z calculated is x bar minus mu 0 over sigma over square root of n, and this is normally distributed. So the z calculated here in this example is x bar 995 minus mu 0, which is 1000 over sigma 25 over square root of n. And this is negative 1.41. Okay, now in order to see whether the z calculated is in this rejection region, we have to find the probability related to z calculated. We have to calculate the p-value. Before doing that, Let's see what the area of the rejection region is. Actually, it is the level of significance alpha 0.05, right? And in the p-value approach, actually we follow this rule. We say that if the p-value is smaller than alpha, then reject H0. And if the p-value is greater than alpha, we cannot reject H0. So let's find the p-value in this example. In order to find the p-value, we have to calculate actually the double of the probability of Z less than Z calculated. Why? Because this question is a two-tailed question. Okay? So let's find this probability. This probability is actually 2 times 0.793. When you double that, you have 68.5. Okay? We have 0.1586. Now we have to compare this with alpha to see whether we should reject it or not. This is the third stage. Now for the fourth stage, we have to compare p-value and alpha, and we see that here the p-value, which is 0.1586, is larger than alpha, which is 0.05. So here in this question, for the conclusion, we say that we cannot reject H0 at 5% level of significance. It means that the sample does not provide enough evidence against H0. So it tells us that the average volume of milk in 1 liter cartoon is not significantly different from 1000 milliliters. So we cannot reject mu equals to 1000 milliliters. Thanks for watching this video.